All right, today we're going to be talking about naming angles, vertical angles, and parallel lines. Make sure you get a note page so you know what to go ahead and do. All right, so we should have this page here. This is our page for the parallel lines cut by a transversal. We're going to talk about vertical angles. We're going to be talking about naming angles, a lot of different things that are kind of happening today. So our I can statement is I can name a given angle. Number 2, I can find the measure of an angle formed by parallel lines and a transversal. And number 3, I can identify alternate interior angles. So this is our goal for today, things that we want to go ahead and do for today. So let's start with naming angles. So angles, yes, you should be filling this in at the same time as me. Angles are formed when two rays share the same point. And what do I mean by that? A ray is where it starts with a point and keeps on going on forever. So notice how this is ray number 1, this is ray number 2, and they have the same point or vertex, which is B. So the vertex is the shared point of the two rays. So that explains this picture right here. And the short form or name of the angle for this one is B. The long form or name of this angle starts with, so the short form of the angle, so that's what we're missing, okay? So notice how I'm going to call it angle, and this should actually have an angle on it too. So angle A, B, C. Notice how the middle point goes in the middle part of the name. And we can also do this backwards. Angle C, B, A. So remember that the vertex or the middle point of the angle has to be in the middle part of the name. Okay, and again, so the vertex should be in the middle. And that's what we just went ahead and did. So here's an example. First of all, how can we draw angle DEF? So E is that middle point. There's an array, so E is this middle point. It's going to come out. And then it does not matter where the D or the F is as long as they are on the outside. Okay, and so then the other question that we have, and this is for example number 2, is what happens when there is more than one angle? And when we have more than one angle, we always give the long name or the long form. So notice how there's more than one angle here, because if I said, oh, I'm talking about angle U, you're like, okay, which one? Is it this one up here or is it this one down here? So how do I draw, how do I draw angle RST? So angle R should be in the middle, S, and then T, right? So here's an example as far as drawing an angle. But on this one here, again, if we are naming angles, if I was talking about angle 1, the name for angle 1 is going to be XUY. And if I was looking at angle 2, and I can also do it backwards. I can do YUX, but notice how the middle vertex is in there. But notice how I have to give the long name of these angles because I don't know which one I'm talking about. And then we have angle YUZ is angle 2. But if I just say, hey, I'm talking about angle U, you're like, okay, I don't know which one. Is it the number 1 or is it number 2? All right, let's kind of move on. Let's talk about vertical angles. Vertical angles are opposite of each other and are formed by intersecting lines. Notice how I have two lines here, and they intersect at G. Notice how I have many different angles that are here. So vertical angles, and this is kind of a cool kind of thing. I'm going to take my trace paper and I'm going to actually show what we know about vertical angles. So I have this angle here. So this is J, F, and then G was in the middle. Okay, and what I'm going to do is I'm going to rotate this and just kind of see what's going on. So if I rotate it, if I rotate it this way, notice I still have that angle, I still have the angle, I still have the angle. Oh, sorry. Notice how I have just barely shown that these two angles, the opposite angles, or the vertical angles, they're exactly the same. So vertical angles are also congruent. They are congruent. All right, well, was it congruent again? Same measure or same shape, right? So if this one here is 30 degrees, that means the one across from it is also going to be 30 degrees. So this is a definition about vertical angles, meaning that the opposites are congruent. So let's look at example number 3. It says find the measure of angle 2 if angle 1 is 115 degrees. If angle 1 is 115 degrees, what is angle 2? Well, angle 2 is across from it, and it's an angle formed by two intersecting lines. Angle 2 is also going to equal 115 degrees. Okay. And we can also find this other angle here if we wanted to, because we know that this is a straight line, right? So if we wanted to find this one right here, that would be 180 minus 115. And that would be that extra angle that's there. So if we grab our calculator and we go, okay, we're going to take 180 minus 115. This would be 65 degrees, right? And if I know this one, the one across from it will also be 65 degrees. So vertical angles are opposite of each other. They're formed by two intersecting lines, and they are congruent. So let's look at example number 4. So if angle 6 is 83 degrees, what would be angle 5? Well, that's vertical, it's across from it. So angle 5 is also going to equal 83 degrees. Okay? All right, let's go ahead and move on to parallel lines. Lines that are always the same, distance apart, and never intersect. That is what is called parallel lines. Lines that are always the same distance apart and never intersect. So what are examples of parallel lines in our real life right now? Well, if you look at the lines down the street, they never, like the lines that you drive within, those are parallel lines. Or like the goalposts, the up and down part of the goalposts, those are also parallel lines. These are things that never cross and never intersect, okay? So if I had this picture here, which ones are parallel? Angle A and B are parallel, and then angle C is what is called a transversal. This is a new word, transversal. It is a line that crosses two or more parallel lines, is what is considered a transversal. So we're going to go ahead and we're going to look at parallel lines, what they actually mean. So let's flip to the back side, and I'm going to kind of come in closer to this. And here I have parallel lines cut by a transversal. So I want to find all these extra pieces of angles. So before we looked at vertical angles, these two angles here, they're congruent. So this is 63 degrees. And then how did I find this one over here? Oh yeah, that was 180 minus 63. Let's grab our calculator. Let's do 180 minus 63. That is 117 degrees. And then if I know this one, I know the one that's across from it, it's also 117 degrees. Now, what I need to find is also this up here. So I'm going to grab my trace paper, and I am going to copy all of these angles down here. So this is 63, this is 117, this is 117, and this one's 63. And I'm going to take this and I'm going to slide this point right here, this point B, along this transversal. So notice how I'm going to slide it along, and I'm going to come up and I'm come up and I'm come up and I come up, and oh, look at that. These ones are also the same as what we had down here. So if I have that, this one is 63 degrees. Notice how this one up here is also 63 degrees. These two angles are what are called alternate interior angles. They are alternate, meaning either side of the transversal. Interior, meaning that they're inside the parallel lines. Notice how these two, they're kind of opposite of each other. They're 63 degrees. If this is 117, that means up here, we'll put this in purple, is also 117. And if I know this one here is 117, across from it is also 117 degrees. And if I know this one's 63, again, vertical angles across from it is also 63 degrees. So notice if I have parallel lines cut by a transversal, if I just know one of the angles, I can actually find all the other ones. And it's because they are parallel lines cut by a transversal. All right, so let's go ahead and let's look at this one here, the one right next to it. If I know, and let's make this a little bit bigger, that this is 34 degrees, how would I find, actually let's do the one across from it, the vertical angle. Remember the vertical angles, they are across from each other and they are congruent. Well, what about this top one? So this top one, I'm going to look at it as, okay, I'm going to make a straight line with this top one. Notice this is a straight line. A straight line is 180 degrees. Notice how I'm looking at, I have 34. So if I do 180 minus 34, let's grab a calculator. Let's do 180 minus 34, and we're going to get 146 degrees. Okay, awesome. So notice how we have 3 of those 4 kind of clumped together. Vertical angles are congruent. This is 146 degrees also. Okay, so if I know that this one is 34, alternate interior across from it is also going to be 34 degrees. If I know that this is 46, or 146, that this one's also 146 degrees. And then we have vertical angles going on, so across from the 146 is also 146 degrees. Across from the 34 is also 34 degrees. Again, notice we have parallel lines cut by a transversal. This is only when it's going to work. So if we look at this one here, are these parallel lines? Notice how this is kind of crooked. Can we find out all the different other angles? So what I'm going to do is I'm going to work with what I have. If this is 108 degrees, that means the one across from it, I'm going to put this in purple so we can see a little bit better, is 108 degrees. And then again, I'm going to make a straight line. Straight line is 180. So I'm going to find this one up here. I'm going to say 180 minus 108. Grab a calculator. 180 minus 108. That's 72 degrees. So then across from it is also going to be 72 degrees. Okay. Notice how this one down here is a little bit different. Notice how up here it's 72, but notice how this is 63. So again, let's go ahead and let's find the one right next to it. I made a straight line. I'm going to say 180 minus 63 degrees. Grab a calculator. 180 minus 63. That's 117. And then across from the 63 is 63. Across from the 117 is 117 degrees. Notice how all of these angles here are different, the ones up here. So that, and the reason why is because these are not parallel lines. You cannot follow the parallel line information. You cannot do that if it only works when they're parallel lines cut by a transversal. So let's go ahead and let's do example number 5. It says, if the measure of angle 6 is 45 degrees, find the measure of the remaining angles. Well, first of all, if I know this one is 45 degrees, alternate interior angles, and kind of one across from it, is also going to be 45 degrees. Okay? If I know that angle 6 is 45, one across from it is also, so angle 7 is also going to be 45 degrees. And then I'm going to go ahead and I'm going to make straight lines again. So here's my straight line. How do I find this one up here? I'm going to say 180 minus 45 degrees, because remember a straight line is 180 degrees. And so this bottom one, so angle 5 is 135 degrees. And then if I go ahead and the one across from it, the vertical angle, is also 135 degrees. Okay, coming up here, if I know this one is 45, up here is going to be 45 degrees. And then again, I can make a straight line. I can say 180 minus 45. 180 minus 45 is 135. That's angle 1. And then angle 4 is also 135 degrees. So notice how we were able to find all of the missing angles if we were given just one of them. And again, this is parallel lines cut by a transversal. All right, so let's look at this last one. This last one kind of entails a lot of different things. So notice how up here we have this is 74 degrees. We want to find all the missing angles is what we're looking for. If this is 74 degrees, across from it is also 74 degrees. Okay, and again, we have a straight line. To find angle 1, we're going to say 180 minus 74, 180 minus 74. That is 106 degrees. I'm going to put that in purple. Okay, and then angle 1 and angle 2 are vertical angles. They're equal to each other. They're across from each other. That's also 106 degrees. Okay, so now what are we going to do? We have a lot of other things that we're looking for, and we want to go ahead and figure out. So I know that here are parallel lines cut by this transversal. This is the only line I'm going to be looking for. Okay, so if I have this one here is 74 degrees. Down here, angle 15 is also going to be 74 degrees. If I don't understand that, I can trace them like we did before. So we have 106, 106, 74, 74. And notice how I'm going to take this and I'm going to slide it down that line all the way until the bottom. Notice how it makes this one down here, 74, 74, 106, and 106. Again, this has to do with parallel lines cut by a transversal. And if you need trace paper to go ahead and do that, that's fine. But I'm going to go ahead and I'm going to label these. So this one here is 74. It was 106. So 74, 106, 106, 74. So 106, 74. Okay, awesome. We're actually getting a little bit closer. Notice how this one down here is 39. That makes angle 13, 39 degrees. And then I have a straight line. So if I'm looking for number 14, I can say 180 minus 39. Grab a calculator, 180 minus 39. That is 141. So angle 14 is 141 degrees. The one across from it, vertical angles, is also 141. Okay. And notice how I've made a triangle. We have a triangle here. This is 39 and this is 74. How do I find angle 11? Well, I know that a triangle is 180 degrees, all of them added together. So if I do 180 minus 39 minus 74, I get 67 degrees. So angle 11 is 67 degrees. Notice how angle 9 across from it is 67 degrees. And then this one here makes a straight line. So to find angle 8, I'm going to say 180 minus 67 degrees. So 180 minus 67, that makes angle 8 113. Vertical angles across from it is also 113. Okay? And then we're going to do the same thing here. Notice how I have a triangle up here. I have 74 and 67. I'm looking for angle 6. So all the angles of a triangle add to 180 degrees. So we're going to go 180 minus 74 minus 67. This is 39 degrees. And then notice how I have vertical angles. So angle 5 is 39 degrees. Notice how I have a straight line. So angle 4, I can do 180 minus 39. Grab a calculator, 180 minus 39. That is 141. And across from it is 141 degrees. So notice how we used parallel lines cut by a transversal definition. We used vertical angles definition, and also all the angles of a triangle add to 180 degrees definition to go ahead and find all of these angles themselves. This is really cool. It's really kind of awesome. So that's today as far as what we're doing. Make sure that we're going to go ahead and we're going to take this, we're going to fold it hamburger style, and we want to tape it into our workbook, and we are going to tape it in we're going to go ahead and tape this on page 120. So go ahead and do it hamburger style, fold it, put it on page 120. All right, so our homework for today is naming angles, vertical angles, and parallel lines worksheet. Go ahead and do those questions, put them into Canvas just like normal. So have a great day. Thank you. Bye, guys.